Hello everyone. Let us continue learning C++ programming. In our previous video, we discussed about functions in C++ programming and the ways of usages and the pros and cons in function overloading, and also a lot of in-depth details about functions in C++ programming, which led us towards polymorphism in C++ programming. Let's get started. So as you already know, the word polymorphism means many forms, which is one of the key attribute in OOPS concepts. And there are two types of polymorphism that can occur. The one is overloading, another one is overriding. Details about function overloading is clearly seen in our previous videos. Now let us concentrate on overriding functionality. Now to perform overriding, there is always a need of inheritance in place. Before getting in detail with overloading and overriding, let us understand what overloading means and what overriding are. So overloading is nothing but bombarding additional tasks to the same function. Overriding is quickly modifying the existing function with a new functionality. In short, imagine a scenario where you use buses. Now, buses are the transport vehicles that are used to transport people or passengers from one source to a destination. And every single bus has a certain fixed capacity. For example, if the capacity of a bus is said to be 50 members, and if it performs the transportation only for 50 members, then it is doing only the task that is assigned to the particular vehicle. And if there is a scenario where we load 20 or 30 more people into the same bus, then the count doesn't matter. If the extra members are added to the same bus on top of the existing maximum capacity, then that scenario is considered to be an overloading scenario. So existing work is being added with more number of works of similar type or same type. So that case is considered to be an overloading scenario. Then what about overriding scenario? Now overriding is a common term which can be heard across most of the science fiction Hollywood movies. And overriding means, imagine the same scenario of buses. The purpose of buses is to transport people from one source to another destination. In that case, if I'm not using the buses to transport passengers, rather, if I use the buses to transport any other goods commodity, like it could be any of the goods where the goods are meant to be transported only through trucks. If I use buses to transport the trucks, I'm completely modifying the functionality to a new set of functionality of that particular function. Such scenarios deliberately explains the function overloading situations. Now, this is in short about a quick note which you can provide to the HRs during a technical discussion. Now let us get into the technical part of overloading and overriding in place. Let's start with creating the file first. And I'm saving this file as program 6.cpp. And I'm starting with our header file includes hash include IO stream, followed by our namespaces. The standard namespace. And here I create a base class. Here I'm having a public member called int data. I'll call this base underscore data. And I have a base constructor. It sets the value of base data to 23. And I create a put function here, which returns the type of void and takes no arguments, which only prints the base data value. And end with a new line character. And I also like to mention a message saying base class put data function. And I end with a semicolon here because any declaration in C++ should end with the semicolon. And I'm creating a derived class here, which does a public mode of inheritance from the base class, where I'm creating a public constructor called derived. Before in hand, I would like to create a member for this derived class as well with the name of int derived underscore data. So there are two members for this derived class. So this basically sets your base data value to 12 and the derived data value to 49 are random numbers. I'm providing it here. And followed by, I'm going to create or copy paste this put data function into my derived class and make it as, this is basically a derived class put data function, and I should print both the data values of base class as well as the derived class. So I'm printing it as base data with a new line character and the derived class data with a new line character. So with this, the inheritance is done, and we have created the same function put data in both the base class as well as the derived class. So let's create our main function first. And in this, I'm creating main. And I create an object for the derived class, namely D. And I'm calling the function of D dot put underscore data and end with the semicolon. And I'm ending the whole execution of the return 0 statement. And I would like to also create an object for the base class as well with the name B. And from B, I'll again call that put data function. Which is a member function of the base class. Let's compile and get the error messages. So let me call the compiler, which is a G++ compiler, followed by the program name, which is program6.cpp. -o, we are supposed to provide the object file name, and I'm calling it as pro6. Now there are several errors in place. Let us plot each and every one. Inside the base class, so third name seems to be error. The function bracket is not needed. A small typos error. Yes, yet another error. And the error means the declaration is not ended with the semicolon. As it mentioned you earlier, any declaration in C++ should end with a semicolon. So the errors are fixed. Let's compile it one more time. And as you could very well see, there are no errors. And this is the perfect code which we have right now. I'll scroll through multiple times for you to make a note of it if needed. And let's run the code again with pro6 as a command. You could see it prints the data. The alignment is not fine. So I include /n characters at the end of each line. I clear the screen, compile it one more time. And let's run this. Now you could see during the first call of b.putData, the base class putData function is being called. And during the d.putData value, the derived class putData function is being called. And this is all about the overloading part. And the moment you start talking about overriding in C++ programming, there is always a mandate necessary of we learn something about virtual functions. In order to discuss in detail about virtual functions, it is mandate that necessary we talk about upcasting, downcasting, that is creating a base class object pointer, and that points to a derived class object and vice versa. So what happens in such scenarios, we'll discuss in detail in our next video, in which we'll talk about upcasting, downcasting, and virtual functions, and also a very key important feature, something called as pure virtual functions. Until then, stay tuned. Happy coding. Thanks for watching. See you in the next part of the video.